This is Ajitha, working as Assistant Professor at Institute of Aeronautical, Dundigal. Today's topic is generation of AM waves using square law modulator and switching modulator. So there are two methods for generation of AM wave, square law modulator and switching modulator. The two methods is going to having a block diagram explanation, and before seeing the analysis of the two modulator, we have to thorough in writing of equations of AM wave and some filters. What is band pass filter? So AM wave equation is AC into 1 plus mu cos 2 pi fmt multiplied with cos 2 pi fct. So this is the AM wave equation. Let us see the first one, square law modulator. Square law modulator, the block diagram square law modulator it contains the three blocks, summer and square law device and band pass filter. So what is filter? Filter is a circuit which accepts the wanted frequencies and rejects the unwanted frequencies. So filters we have low pass filter and high pass filter and band pass filter and band reject filters. So what is band pass filter means? It is going to allow some band of frequencies. Some band of frequencies from, suppose from F1 to F2, it is going to allow. Remaining frequencies it is going to reject. That means 0 to F1 is called stop band. F2 to infinity is also called stop band. And F1 to F2 is called pass band. So as we know, AM wave contains upper side band and lower side band terms. Upper side band term is Fc plus Fm and lower side band is Fc minus Fm. So band pass filter is designed such that it is going to allow from Fc minus Fm to Fc plus Fm. So always band pass type filter is there in modulator, and demodulation, as we know, demodulation is done in receiver. Demodulation is done at the receiver. What is demodulation? Recovery of the message signal. So we are going to recover m of t from modulated wave. So we are going to recover this m of t from the modulated wave. As we know, modulated wave is higher frequency and this m of t is the lower frequencies. So at the receiver, we want only low frequency term. So obviously we are going to select the low pass filter at the receiver. But in the modulation, we want to transmit from upper side band to lower side band. Some band of frequencies we want to transmit. So it obviously requires a band pass filter as the block. So in the square law modulator, we have three blocks, summer block and square law device block and band pass filter block. As we know, summer inputs are message and carrier. So sigma means summation. So V1 of t is the output of the summer block and V2 of t is the output of the square law device and S of t is the output of the band pass filter. So we'll write one by one the expressions of V1 of t and what are the characteristics of the square law device and what is the expression for V2 of t, and finally if V2 of t is given for band pass filter, what is the output? What is S of t? These three terms we will clearly do in the analysis. So V1 of t, summer block output, that is message and carrier both are going to add it together. So M of t is the message and AC 2 cos 2 pi fct is the carrier. So this is the V1 of t. And as we know, square law device, if we take this example, diode we can take it as a square law device. Square law device means its output equal to input square. Output equal to input square. If we observe diode characteristics in forward bias, this is the diode characteristics in the forward bias, forward voltage and forward current. As we know, before the cut-in voltage, we have a curve like this. This is called square wave region. After cut-in voltage, it is going to conduct, so it enters into linear region. So diode, we can consider this region as a square law device. So we'll write V1 of t as a input for the diode and V2 of t is the output of the diode. We will write this diode V2 of t non-linear device characteristics V2 of t output as, it is not linear, it is a square law device. We will write as K1 into V1 of t plus K2 into V1 square of t. This is the characteristics of a diode in non-linear region, that is before cut-in voltage. So V2 of t equal to K1 into V1 of t plus K2 into V1 square of t. This is the characteristics of a non-linear device. Here K1 and K2 are the constants. We know V1 of t is the summation of message into carrier. So we'll replace message plus carrier as the V1 of t. And we will replace V1 square of t also. We'll simplify this V2 of t. So V1 square of t means m of t plus AC cos 2 pi fct, message plus carrier summed up together and square of the term. Apply here a plus b whole square and separate the terms because this V2 of t again fed back to the band pass filter. So there we have to analyze each and every term, whether the band pass filter allows this term or rejects this term. So for seeing this one, we are going to expand all the terms individually. So apply here a plus b whole square, a square plus b square plus 2ab. So here it will become a square is m square of t, b square is ac square cos square 2 pi fct. This is the a square b square 2ab. 2ab is 2 into m of t into cos ac cos 2 pi fct. This is the first term and this is the k1 into v1 of t and k2. This total term is k1 into v1 of t. This term is k2 into v1 square of t. And after expansion, here we are going to see v2 of t equal to first term k1 into m of t. What is this term? K1 into m of t is message signal. What is k2 into m square of t? So we are going squaring of the message signal. Third term k2 into ac square into cos square 2 pi fct. This is the third term. What is the term here? The term is carrier only, ac square cos square 2 pi fct term. And this is purely message and this is message square and this is the carrier square. So please understand each and every term. And the second term, two terms, this term and this term, we are going to see AC cos 2 pi fct as the common. So AC cos 2 pi fct as the common in the two terms. If we take the common AC cos 2 pi fct, K1 AC cos 2 pi fct as the common, we are going to get the 1 here and here we are going to get 2 K2 by K1. Here K1 is not there, so it is going to divide here 2 K2 by K1 into m of t. So this is the term common in this one. Okay, so after getting this term, what is this term? This term is actually looking like a AM wave term. AM wave term is AC into 1 plus Ka m of t into cos 2 pi fct. This is similar to AM wave term. AM wave term. Fourth term is the required term, that is the AM wave term. First term is purely message, low frequency signal, m square of t. This is also message signal. And the third term, carrier square term. There is no message into carrier term. When the message into carrier term is there, then only we are going to get upper sideband and lower sideband. And from the second term and the fourth term, we are going to take the common K1 AC cos 2 pi fct as the common. Then we will get 1 plus 2 K2 by K1 into m of t. This is the total amplitude of the signal. K1 AC into 1 plus K2 K2 by K1 into M of t. This is the amplitude of the signal. So this is given for band pass filter. This V2 of t is given for band pass filter. In the block, V1 of t is given to square law device and V2 of t is given as band pass filter. So band pass filter is designed such that it allows only frequencies upper side band to lower side band. And here we'll see fourth term is going to yellow. Fourth term is going to yellow from the band pass filter. First term, second term, third term is going to reject by the band pass filter. Band of frequencies only allows. It allows from Fc plus W, Fc minus W to Fc plus W. This is called designed such that it allows only Fc minus W to Fc plus W. So fourth term allows through the band pass filter. Why first term is not allowed means, if you observe the spectrum here, M of t. So message signal, first term is K1 into M of t. What is its spectrum? Its spectrum occupies at the 0, nearer to 0. 0 W to minus W. This is the M of t. This is the M of t. So lower frequencies will not allow from the band pass filter. So this is rejected. First term is rejected. Second term, K2 into M square of t is the second term. What is M square of t? If we apply the M square term, it contains 2W and minus 2W. 2W and minus 2W as the frequencies. So 2W and minus 2W also lower frequencies only. So band pass filter is going to reject. And we have one more term is there, the carrier cos square 2 pi fct. If we convert cos square 2 pi fct, cos square 2 pi fct, we are going to get 1 plus cos 4 pi fct by 2. Cos square theta, 1 plus cos 2 theta by 2. This is also trigonometric term. We can use this 1 plus cos 2 theta by 2. Now the frequency first term is 1 by 2 DC component and the second term is 1 by 2 into cos 2 pi into 2 fc into t. So DC term is rejected by band pass filter and 2 fc is also rejected by band pass filter, because band pass filter allows from Fc minus W to Fc plus W. So this is the spectrum. This is the spectrum of 4 terms. First term is message, M of t spectrum, this one. And this is the M square of t spectrum. It occupies from minus 2W to plus 2W. And we have one more carrier, AC square 4 cos 4 pi fct term is there. 4 pi fct means its spectrum occupies from 2fc and minus 2fc. So this is rejected by band pass filter. This term is also rejected and this term is also rejected. Only it allows Fc minus W to Fc plus W. So this is going to pass it through the band pass filter. This is the positive side and this is the negative side. This is the band pass filter. Dotted line is shown in the band pass filter response. So this response only allows this term and rejects all other terms. This is about the square law modulator. So in the circuit point of view, we have modulating signal and carrier signal combined together and given for nonlinear device which exhibits the characteristics. What are the characteristics of nonlinear device? Here is V2 of t is the output of the nonlinear device. It is K1 into V1 of t plus K2 into V1 square of t. K2 into V1 square of t. And V2 of t is given for tuning circuit, and tuning circuit tuned to carrier frequency. This tuning circuit is tuned to carrier and surrounding upper side band Fc plus W to Fc minus W. The tuning is, designing is such that Fc to Fc plus W and Fc to Fc minus W. This is only allowed for this filter. This is the output of the band pass filter. This V0 of t is only the fourth term. The fourth term is this one. K1 AC into 1 plus 2 K2 by K1 into M of t multiplied with the cos 2 pi FCT. This is the output of the square law modulator. If we compare with the standard AM equation, we know standard AM equation. In terms of Ka, we have the term 2K2 by K1. What is Ka? Ka is called the amplitude sensitivity. Ka is called the amplitude sensitivity. So this Ka equal to 2K2 by K1 for square law modulator. This K2 and K1, it depends on the device. Non-linear device we are going to using for the modulator. K2 and K1 are the constants. 2K2 by K1 is called the amplitude sensitivity of the square law modulator. This is the first modulator, square law modulator for the generation of AM wave. And the second modulator is switching modulator. Earlier modulator and this modulator difference is, earlier the diode or non-linear device we are going to use as a squaring device. Here the device acting like a switch or like on and off mode. The diode will consider is a on and off mode. So here also same blocks are there, summer, message and carrier, but the device is operating in a switch mode, on and off mode, and again the band pass filter for passing upper side band Fc plus W and lower side band Fc minus W. Fc minus W to Fc plus W is going to pass this band pass filter. Band pass filter output S of t is AM wave. AM wave. Now see the analysis here. Switching modulator is similar to square law modulator only, but here the diode is operated in non-linear mode in square law mode device. But in switching mode, diode is operated as a ideal switch. So V1 of t again that will consider the summation of message and carrier M of t plus C of t. M of t plus C of t is AC cos 2 pi FCT. The signal V1 of t is applied for the input of a diode. As we know, here we are applying message plus carrier as a input for the diode. Now we will consider one condition here. The condition here is the magnitude of the modulating signal is very small when compared to amplitude of the carrier signal. So carrier signal amplitude is more than AM. AC is more than AM. As we know, AM by AC less than 1 for under modulation. Mu less than 1 case under modulation. So carrier amplitude is more than modulating signal amplitude. Why we are considering here? Diode, we know diode is going to forward bias and reverse bias. So diode will become forward bias and reverse bias. When it will be forward bias, when this potential is more than cathode potential, it will become forward bias. So diode is operating forward bias and reverse bias. So the controlling voltage at the input of the diode is completely carrier, because the carrier amplitude is more than message signal amplitude. So on and off action of the diode is controlled by carrier signal C of t. We know when C of t is greater than 0, that means the potential at the anode is more. So diode is in forward bias. And when the potential at the cathode is less, when the cathode is more, then it will become reverse bias. So carrier is positive, diode will become forward bias. So when diode is forward bias, switch is closed. We know switch is closed. When reverse bias, switch is open. So this is the application of diode in forward and reverse bias. The same application we will use here, but switch operation is controlled by completely carrier. Carrier positive, forward bias, carrier negative, reverse bias. So this is action taken place here. X of t, this X of t is the modulating signal, and this carrier wave is called highest magnitude signal. So carrier wave magnitude is more than message signal. So switch action. We know switch action means carrier positive it is off, on, and carrier negative it is off, on, off. It is like a periodic square wave. Switch operation we can estimate as periodic waveform. So we know that V2 of t, it is the output of the switch. Output of the switch is when it will be forward bias, when carrier is positive, forward bias. Forward bias means like the switch is going to close. Close means what happens? This V2 of t is connected to V1 of t. V2 of t is connected to V1 of t. So V2 of t equal to V1 of t if carrier is positive. If carrier negative, what happens? Diode is reverse bias and switch is open here. Here it is closed and switch is here open. So V1 of t does not pass through V2 of t. So V2 of t equal to 0. So V2 of t equal to 0. If C of t less than 0. This is reverse bias. Now the switch action, we will call it as, like if we understand carrier positive, negative, carrier cycles are there like this. And the switch action we will see carrier positive here, so switch will be closed, and carrier negative here, switch will be open. Open means 0 output. Again the positive voltage of carrier, again the switch open, closed, again the switch closed. This type of action is performed in a switch open and close. We'll call this signal as X of t. Periodic on and off action. Periodic on and off action, that is periodic square wave, that we will call it as X of t. Now V2 of t we can approximate as V1 of t multiplied by switch action. Switch action is controlled by X of t. What is the period of this X of t? The period of X of t is the period of carrier wave, because on and off action is controlled by carrier. So the period of X of t is also 1 by Fc. So mathematically we will write as V2 of t is the diode output, V1 of t is the diode input, but diode input is controlled by carrier. Carrier positive, it is forward bias. Carrier negative, it is reverse bias. So this condition is going to write in terms of one more signal X of t. Okay. So V1 of t multiplied with X of t is the V2 of t. So this is a periodic on and off action. So this is a periodic signal X of t. If we convert in Fourier domain, we will use Fourier series concept for writing the Fourier series for conversion of this signal to frequency domain. To find the harmonics of a signal, we will use the Fourier series. So Fourier series used for this pulse train. So Fourier series formula for this one is X of t is 1 by 2 into 2 by pi plus summation n equal to 1 to infinite minus 1 power n minus 1 by 2n minus 1 cos 2 pi into 2n minus 1 into Fc into t. So here n is varying from 1 to infinite. N is varying from 1 to infinite. First term 1 by 2 is called DC term because there is no frequency term. This term is called the DC term. 1 by 2 is the DC term. Suppose n equal to 1, if we expand this term, 1 minus 1 power 0 by 2 minus 1, that is 1, cos 2 pi into 2n minus 1. 2 minus 1 means Fc. So n equal to 1, we are going to get the Fc terms. N equal to 2. N equal to 2 means we are going to get 2n minus 1. N2 means what term we are going to get? 2 into 2 minus 1. That is 4 minus 1. 3 Fc frequency we will get. We are going to get the 6 pi Fct term. Similarly, N3. N3 means 2n minus 1. 2n minus 1, 2 3s are 6 minus 1. That is 5 Fc. 5 2s are 10 pi Fc. Next term frequency is 10 pi Fct. So like this we are going to get the harmonics of the Fc. First term contains the frequency Fc. Second term contains the frequency 3 Fc. and the third contains the frequency 5 Fc. So it contains the hard harmonics Fc, 3 Fc, 5 Fc, 7 Fc and so on. And each amplitude depends on the term. This term is called the amplitude of the harmonic. This term is called the amplitude of the harmonic. First harmonic amplitude, suppose n, if we keep n as 1, we are going to get 2 by pi as the amplitude of the harmonic, first harmonic. And 3fc harmonic is, 3fc harmonic means n equal to 2. N equal to 2 means minus 1 power 2 minus 1 by 2 into 2 minus 1. So we are going to get extra 3 as in the denominator for 3fc harmonic. It is minus 2 by 3 pi. So this is called the amplitude of that harmonic. 2 by pi first harmonic amplitude, minus 2 by 3 pi, that is the second harmonic amplitude. So this x of t is expressed in Fourier series. This is the Fourier series formula for periodic pulse train. We can use it for the x of t approximation. So x of t finally contains what are the terms? First term DC term with amplitude 1 by 2. The second term is the frequency Fc with amplitude 2 by pi. And third term contains the frequency 3Fc with amplitude minus 2 by 3 pi and so on. 5C term, 7Fc term and so on. Odd components exist for infinite terms. Now what is V2 of t? V2 of t is V1 of t and switch action is approximated as periodic pulse train x of t, and this periodic pulse train approximation is done in Fourier series, and we have the Fourier series expression for this. We are considering the first 3 terms. If we consider more terms also, they are going to reject by band pass filter. Now V2 of t equal to x1 of t, V1 of t multiplied with x of t. This is the V1 of t and this is the x of t. If we multiply these two terms, what is the first term? We are going to get m of t by 2. This term and this term if multiply, m of t by 2. Second term, ac by 2 into cos 2 pi fct. This is the first term, second term, and the third term 2 m of t by pi into cos 2 pi fct. This is the third term. And fourth term 2 ac by pi into cos square 4 2 pi fct. This is the fourth term. And 6 pi fct multiplied with m of t, fifth term and sixth term. So these different terms are given for band pass filter. Similarly, as we did in the square law modulator, we have to consider the each term and what is the frequency contained in each term, and the frequency is allowed by band pass filter or not. We will check each term by term. Generally, it accepts only AM wave because band pass filter is designed to for Fc minus W to Fc plus W. When this band of frequency occurs, when time domain m of t into cos 2 pi fct. When message and carrier both are multiplied, then only we are going to get the lower side band and upper side band. So in the first term, we have m of t by 2. This m of t by 2 is, we will take cos term, where the cos terms are there, we will look into the terms and we will take the common here. Here the AC by 2 cos 2 pi fct is there, and here also m of t by pi into cos 2 pi fct is there. So from these two terms, we will take the common AC cos 2 pi fct. AC cos 2 pi fct, because the common is there, because the frequency in this term is Fc and the frequency in this term is also Fc. So from 2 and 3, take the common AC cos 2 pi fct. So first two terms, if we take AC cos 2 pi fct as the common, we are going to get total term, we are going to take the common. If we take AC by 2 into cos 2 pi fct common here we are going to get 1 plus remaining term here, AC by 2 is not there. So we will multiply and divide by AC by 2 into 2 by AC. So we'll get the 4 by AC into 4 by pi AC into m of t into cos 2 pi fct. This is similar to AM wave equation. AC into 1 plus KAM of t into cos 2 pi FCT. This is the term. And the remaining terms as usual, m of t by 2 and 2ac by pi into cos square by 2. Remaining all the terms we will, as usual, will write. And the first term is the desired AM wave equation. First term is the desired AM equation. This is allowed by band pass filter. This is allowed by band pass filter. And the second term is message, pure message. What is the message signal? Band pass filter is designed such that this is the band pass filter. It allows Fc minus W to Fc plus W. It allows Fc minus W to Fc plus W. First term comes under this range only. First term is like this spectrum. So this term is allowed. But second term m of t by 2. M of t by 2 means it occupies W minus W to W. So band pass filter does not allow, so it is rejected. This is rejected. Third term is 2ac by 2 into cos square 2 pi FCT. Cos square theta again convert into cos 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. One DC term will come here and 2FC frequency comes here. 2FC means more than FC plus W. So 2FC and 2FC, these two also rejected. So third term is also rejected. And the next term, the frequency is 3FC. It is also rejected. And next term 2 pi FCT multiplied with 6 pi FCT. Here the frequency is 4FC will come. Again the 2FC will come. So more than FC, 2FC, 3FC, 4FC, all are rejected by band pass filter. So only the first term is going to pass through the band pass filter. If we compare this equation with standard AM equation, so here in place of Ka value is 4 by pi AC is called the Ka value. Ka is 4 by pi AC. And all the terms are eliminated. So output of the band pass filter is this one. So amplitude sensitivity of the switching modulator, we'll call it as 4 by pi AC as the amplitude sensitivity of the switching modulator. Here the amplitude is AC in the standard equation, but output of the switching modulator is AC by 2. So we'll call it as scaling factor of 0.5 for switching modulator. So this is about the generation technique of AM wave by using square law modulator and switching modulator. In both the cases, the operating diode we can use for the two applications. For the first application, diode should operate in non-linear region, square law device. And second one, switching modulator application, diode can use as a diode like switch on and off. The on and off action is written in using Fourier series, and Fourier series approximation we will use for V2 of t equal to V1 of t into x of t. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.